Hello friends, we will discuss today on the topic of Geographic Information System. As you know, Geographic is the study of Earth. So this Geographic Information System is doing something with maps and something also with the computer. And to formally define this Geographic Information System as GIS, it is an organized collection of computer hardwares, softwares, geographic data and personal design to efficiently capture, store, update, manipulate, analyze and display all the forms of geographically referenced informations. And when you take up the history of this GIS, so it is a long history, so it is dating back to the early men who lived in caves. So they represented pictures in the form of the animal pictures where they hunted in their caves, in the walls of their caves, and these actually represent the two type of data that is depicted in the modern geographic information system, that is the picture associated with an attribute data. So this formal GIS started with John Snow in 1854 who depicted the cholera outbreak in London using some points of individuals who are affected by cholera. So this was the first GIS map in 1854, followed by in 1962 the first world or operational GIS was developed by the Federal Department of Forestry and Rural Development in Ottawa. So this is called the Canadian Geographic Information System, and this was the first formal geographic information system that is being developed. Later in 1964 Howard T. Fisher formed the laboratory for computer graphics where the major development of GIS took place, and in later 1980s this MRS computing, later Intergraph, then ArcGIS history and CARIS emerged as a commercial vendors for GIS softwares. As you can see in the GIS, there are two different things. One is what are the components and what are the functions of GIS. First we will concentrate on the components of GIS. So when we see the components of GIS, so there are different components that make up the geographic information system. First thing is the softwares. So software gives the user interface, so where we can operate or bring up the data or what we have into an user friendly form. And second one is the hardware, where we store all the data that or the information we collect. And third one is actually the data. So there are different types of data, maybe a spatial data or non-spatial data. Then spatial data are georeferenced, and when the non-spatial data are simple table forms. So all these data can be stored into the hardware and we can manipulate with the use of the softwares. So the fourth component is the user. So user is nothing but the ultimate user of all the information. So based on the user needs, all these GIS components work. And fifth one is the procedures or the methods that is coming with the software or the tools that can be used by the user in order to interpret or manipulate the data that we have. So the second part is the functions of the GIS. We have many functions of GIS. The first part is the data capture. It is nothing but the inputting of data what we have. So we may be having a paper maps, and that map has to be taken first into a digital form. So this can be done in two ways, either by digitization or by scanning. So digitization is a method where we take up the map with points and nodes, and scanning, again you know, by scanning it can be made to a digital form. The second type is the point data that we collect from GPS, and even the tabular data that we have in a hard copy, that also can be digitized, that is by typing into an Excel or it can be into an database management system. And second part is the data manipulation. Whatever the data that is being taken or inputted into the GIS system, it can be manipulated. So there are different types of manipulation techniques. One is the map merging. Say we have a larger area map in a split up forms, then all these split up maps can be joined together to form a whole area. and second one is a spatial subset. So we have a larger map, and when we need a smaller area or the area of interest, we can just cut out a simple area or area of interest from that whole map. And third one is the boundary dissolve. Say we have many polygons or different areas, we can, with the attributes, we can dissolve those points into a final map that can be more informative than the initial map. And third one, when we come to data management, so we have the data management is nothing but the relational database management in GIS softwares. So it is different from that of the database management what we have, that is from the SQL or other softwares. So relational database management is nothing but the database management that is having some relation with the spatial coordinates, with the spatial coordinates. So we have two things, one is the attribute database and the spatial database. These two combine to form or linked together to get a final database output in the GIS. So this is possible in GIS. Fourth function in GIS is the data query. So as by the name, it is a querying of data. So whatever we have stored in the form of digital data in the GIS, it can be queried for many things. So as far as where is it, so we can see for an example. So when we have a soil map and we have some attributes to that soil map, we can query in such a form that where or which soil is suitable for sunflower production or some crop cotton production or for some other crops. So as far as what is at, so it is nothing but, so it is a querying where which type of dominant soil is suitable for paddy. So this also can be done by data querying. So and what has changed, this is also possible. Say we have a data of 1998 or some earlier data, and we can compare to that with that data with the recent data. Say in this example I have quoted the changes between 1998 and 2010 for paddy production. So this also is possible with the functions of GIS. And last one is what if. It is a nothing but the modeling type of querying. The next thing is the data analysis. This is the fifth function. So wherein whatever the data you have inside the GIS, it can be analyzed in different ways. So first form is the overlay. So you can see from this example you have two different maps, that is the input, and this can be overlaid to form a single output. And in the second form you can see it is a proximity analysis. This is nothing but you are making or making a polygon even from a point, line or a polygon feature itself. So you can find out the approximate or the influential area from that point. So this is also possible in data analysis, and this is one of the main functions of GIS. And last but not the function is the data display or visualization. This is nothing but, so whatever the data or analysis that you carry out in GIS, it has to be forwarded to some outputs. So this is the last function in GIS. So that is the output may be in a screen form or it may be brought out in a hard copy form. So if it is in a screen form or a visualization, it can be a monochrome or color or various sizes and resolutions. If it is brought out in with a plotter or into a hard copy, you can print out the analysis or the maps from the GIS. And it can also be need based, whether you can change the scales, projection capabilities, and another annotations also can be added to some maps, and it can be brought out as an output. So the next thing is the data representation in GIS. As you see, there are majorly two types of data that can be kept in GIS. So first thing we will see about describing our world. So any point in the world can be described in two ways. So one is the location information, that is where is it, and second one is the attribute information, that is what is it. So these two types can be given out or represented in two forms, one is the vector form and second one is the raster form. So vector is nothing but points, lines and polygons. Say when we depict a city or a building, it can be given as a point. Then when we are representing some rivers or a linear features, then it can be given as a line. Or again we have to, when you are specifying an area, then you are giving out as a polygon. So when all these features, say points, lines and polygons, these are called vector themes. Then coming to the raster themes, it is nothing but the images. As when we take a photo, so all these photos are formed with pixels. These pixels are arranged in rows and columns. So this is the raster type of themes. So these are the major two types of data that is represented in a GIS. The second thing is an attribute data, that is nothing but a tabular form, that may be in Excel or some data acquiring languages, okay, SQL or something else. Then even a new tables can be formed and that can be added to the GIS maps. Then what I said is the raster and the vector. So you can see in this slide, so first thing is the raster, you can see the map with pixels, and second one is a vector map of the same area with polygons, lines and points. So this is how it is represented in a GIS platform. So again, so how these points are kept in a GIS? So points have just x and y coordinates, whereas a line, it has a series of xy coordinates, the starting and end it will not be matching. When coming to an area or a polygon feature, it also has a series of xy coordinates, the first and the last xy coordinates will be the same. So that forms a curved surface. As far as a data model, a vector model, when it is represented as a point, in a raster it will be represented as a pixel. When it is a line in a vector model, then in the raster model it has a series of pixels. And similarly when you are depicting a circle or some area in a vector model, again in a raster it has number of pixels that accumulate or give the shape of a area that is formed by the vector file. So let us see the spatial analysis that can be done with GIS. The first thing is data modeling. So for example, we will take a watershed delineation from a DEM. So DEM is nothing but the digital elevation model. So from digital elevation model you can just calculate the slope, you can make contours, you can make reliefs from that, and using all these things, using a buffer analysis, you can create a watershed or delineate a watershed from the data. So this is how the data modeling works with the spatial analysis. Then second one is the topological model, that is you have different topological modeling, that is topological relationships can be done with topological modeling. So first thing is adjacency, that is what adjoins what, say a soil with a crop or some soil with adjacent soils. Then containment, what encloses what, that also possible. And the last thing is the proximity, how close something is there with something else. So that is also possible with the spatial analysis with GIS. The third one is the network analysis. As we have this is an important analysis in GIS. So this is applicable in transportation planning, hydrology modeling and some infrastructure modeling also. So we can find the easier or very effectively the routes between one point to another. So that is possible, and the flow from higher end to the low, so that is also possible with the network analysis. And fourth one is the cartographic modeling. So this is nothing but the thematic layers of same area that can be produced, processed and analyzed. So this was first coined by the Tomlinson, that is the father of GIS. And the fifth one is the map overlay. So we have many analysis with map overlay, say union, making two maps together intersect. So we can take or pick out the intersection point of two maps. And the third one is the data extraction. So that also possible with map overlays. And last one is the geostatistics. So the major advantage of spatial analysis in GIS is this one, geostatistics. We have some interpolation tools named IDW, kriging, etc. So we can find out an unknown point with the known points. So this is also possible with all these types of spatial analysis in GIS. So in order to conclude, so in GIS we can make static map into dynamic. So a paper map can be made more dynamic when it is formed or transformed into a digital form. Then GIS provides a worksheet for mapping spatial informations. So we have latitude and longitudes, we can locate each and every location on the earth. Then third one, GIS maps spatial objects into a graphical features, that is also possible. Then GIS links graphic features and with a tabular data. So when you are having just a tabular data, that can be directly included if you have some links with the latitude or longitude or with the spatial data. Then GIS can display spatial data as themes, say separate themes of soil, crops, land use, all this is possible with GIS. Then GIS provides a variety of analytical tools that you can use to get out some information from the maps. Then GIS can provide as a tool for presenting spatial data. So all these are possible with the GIS. So the success of GIS depends on the user. So when a user has some information or whatever he needs, he can derive from GIS or use this GIS tool to derive the information what he wants. So all the success of GIS depends on the final user. So here I have given some of the popular softwares that is used in GIS, say ArcGIS, Geomatica, Geomedia, MapInfo, and many other softwares are there. So all these softwares what I have given now are proprietary softwares, and even there are open source softwares available for GIS, so with limited options, and that also can be utilized by the users. Friends, with this I conclude my session with the GIS. So for any queries, you can contact the Manage website or the materials that have been distributed to you. Thank you.